and tricks. So I sort of got this idea from last lesson. A lot of students, so I think it was mostly based off Alethea, because she was like saying, oh, it makes a bit more sense once you sort of know some of the tricks. I thought, well, maybe I'll just actually write down what the tricks are that I've been using to solve these pedigree questions. So let's talk about last lesson and then bring that up and talk about the tips and tricks. So last lesson we started talking about what a pedigree is. I said a pedigree is like a scientific family tree. It tracks not just who's related to who, but also who has a particular trait. You could track people with blue eyes, you could track people with attached earlobes, you could track any number of things. And we use pedigree charts all the time to sort of figure out what's going on, what are the likelihoods of certain things. Now, because of pedigree charts, because of pedigree and genetics, it can be the certain situation that a particular trait, you might have a particular trait, but then your parents don't. But you then might have an auntie or an uncle or a cousin that also has that trait. And that trait might be hidden in your parents' DNA. This is why, for example, when women get tested for breast cancer, they always pay attention to say, well, look through the rest of your family. You might have an auntie or a cousin or a grandmother that has breast cancer. So, but even though your mum doesn't get it or something like that. So just, that's why these things show up. How do we draw a pedigree chart? Squares are for boys, circles are for girls. Find your own way to memorize that. Up to you guys to figure it out. Lines connecting them are people that have gotten together and had children. Their children are lines that come down from them. So if a man gets together with a woman, their children will be down. And then if they have additional children, then they'll also be down from that point. Each generation is written in Roman numerals, I, so on and so forth. And each individual has their own number. And we saw with this one, the numbers are not really related to who's related to who. The numbers are just so that if you're talking about, can you explain generation 1, person 3? And I can be like, yep. Well, generation 2, person 4, yep, this person here. Rather than saying, oh, this person, who's this person, just reading it off a grid. People with the trait are shaded in. And then we started off by looking at this family here. And we were looking at, we said the first problem with this was it can't be two mothers, it has to be a mother and a father. We said these two are related because they are father and daughter. And we said red hair is what we're going to be looking at. So we said, well, this one here all these are lowercase, sorry, not R's. I did the same problem again. All these are lowercase h's because they have abnormal hair. They have red hair. Whereas, this guy here must be a capital H and a lowercase h because it needs to get this person needs to get one of its genes from its mom and one of its genes from its dad. And because we know they haven't got red hair, that means that it must be a capital H because it has to have a dominant gene. This lady, she could be HH or she could be H lower H. And then we did the same thing for the rest of the family. Where I wanted to take this is I wanted to take this one step further. So I always put the recessive ones in because they're the easiest ones to work out. And then I would then go about putting the other ones in. I know that this one has to be capital HH because this person needs to get one H from his mum, but also one H from his dad. And so if this was capital H, no chance. This has to be lowercase h. Now, at this point here, then we could say, well, this person is a carrier and this person is also a carrier. And then we know that this person has to be a carrier. We knew that, and we kept going, I think. All these people are carriers, but we don't know about this man. This man is either HH or this man is H, lowercase h. We have no idea of knowing because if this person never had a child with red hair. This person did have a child with red hair, so we can lock in that it's lowercase h because they must have one, or else this one wouldn't be able to get one. This one we don't know. Could be the roll of the dice. Could be the next one, next child this couple had could have had red hair, or it could have just been it's capital. This person's capital H, would never be able to have a red-haired child. But yeah, we'd have to figure that out. What the last thing I wanted to do with this scenario is I wanted to bring in this. So Uncle Dave finally got married, yay! And to this random woman. Okay, we don't know her genetics at all, but we do know that she has normal hair. Because she has normal hair, one of these has to be a capital H. Okay. Now, we can then say, well, let's look at her children. So their children, are here. Now, their children are going to be, no matter what, they're going to be hybrids because the father can only ever offer a lowercase h. And therefore, in order for them to have normal hair, they must have a capital H. But it doesn't answer the question. Where it's the same sort of thing that this person here is the same as this person here. It does not answer the question whether or not this person's capital H, or capital H, lowercase h. We don't know which one. Because if it was capital H, then that would mean, yeah, all their children would be hybrids. But if it's capital H, lowercase h, their children would either be hybrids or they could have red hair. Let's actually look at that for a second. Just really briefly. Let's take those two scenarios. Here is the scenario. So here is the scenario where she's capital H, and here is the scenario where she's capital H, lowercase h. If we look at this scenario at the top, then all of their children (100%) are going to be HH. Whereas if we had this situation, (50% would be HH, 50% chance of getting HH. So, and the thing is that if we knew that she had a red-haired child, it would definitely be this one here. But she hasn't. So it could be either she's always gotten this one on the left, these two on the left, or it could be that she is just HH. The more normal haired children she has, the more likely that it's this one, but you can't say for certain. Because again, it's that whole idea of, it's the whole idea that I think I taught some of you guys this last year. No, I didn't, because I didn't have you guys last year, but it's the whole idea of probability. Doesn't matter how many times you flip that coin, just because it comes up heads 9 times doesn't mean the next time will be tails. And I guess in this situation, it sort of says, it doesn't matter if you flip that coin 9 times and it comes up heads, it doesn't mean that it is it's a 2-headed coin. You just don't know. Oh, really quickly, by the way, guys, how do I number this new person? What number are they going to be? What number are they going to be? Actually going to quickly unmute everyone. So if you're having a conversation about something, you shouldn't be. You should stop now. How do I number this person here on the right?
Wait, can you do it?
You're bloody.
Are they that one?
Yeah.
Isn't it going to be 2, 7?
Number them.
II7. Good. And this one down the bottom?
3. I.
I1.
3. Oh.
3. Oh, crikey, you're right.
3.
I thought I was wrong, and then 4.
Yeah. So it's 3 because we go 1, 2, 3, 4, and we just read from left to right. We're not trying to. We don't. Doesn't matter that it's like, oh, but I3, but I3 is here. It's like, oh, but doesn't that mean no? Doesn't matter. We just label it left to right. So what are some things that I've learned? I'm going to mute you guys again. What are some things that I've learned? No offense, from doing this. Here are some tips and tricks, and this is the last slide. Oh, second last slide. So some tips and tricks that I've sort of picked up along the way is this. If a
Did we do this period 2?
well, no,
Or
we started this period 2. We're finishing off today. So I'm talking about tips and tricks now.
Oh, okay.
So if someone has a recessive trait, then they must be homozygous recessive. What does that mean? That means that if you have a recessive trait, like let's use G. You have a recessive trait. Well, let's do B. Sorry, lowercase b. You have to be both of them recessive. Okay. Might seem obvious, probably won't seem obvious because I know this is new to you guys, but a lot of people will, that's the first one that I fill in. I just go, right, I know that you're recessive, so that means you have to be lowercase b, lowercase b. I knew if you were capital B, lowercase b, then that wouldn't be recessive. This one would take over. If you were capital B, there is no recessive at all. So I know that if it is a recessive, if you possess a recessive trait, then you have to be lowercase b, lowercase b. The second trick that I usually use is that that wasn't supposed to happen. Oh, well, doesn't matter. The second trick that I use is I always go, you must get one gene from each parent. If I've got lowercase b, that means one of these has to come from the mum and one of these has to come from the dad. That means that, for example, in this situation here, this couldn't be capital B, because then there would be no place for this person at the bottom to get their lowercase b, to get their recessive B gene. There is just no place for it. And of course that person is not lowercase b, because then they would be a recessive trait. And the last, I guess, tip and trick here that I'm going to throw up here is it is possible to not have enough information to determine the genotype. If a capital B person, BB, gets with a lowercase b, well, that's wrong. Ooh, that's wrong. Oh, yeah, don't look at that. That's wrong. Let's have a look at why I got it wrong. Because I broke my second rule. This is impossible, right? Where is this person going to get this capital B gene from? So what I'm going to do is I'm going to fix this slide, and then we're going to talk about it briefly. So how do I fix this slide? Quite easily, ladies and gents. All I do is I'm going to change this, and I'm going to make it white, because I'm going to say this person is not showing this gene. I'm going to change this to a capital B. Capital B. Sorry, guys. There we go. So this is the last slide, so it doesn't matter too much. So we can't know from this information whether or not, because either this person's got a white color, this person's got is showing the dominant gene. So that means it's either BB or it's BB. But we don't know which one of these is the case, because it's very likely that it's BB, because it's one B from the dad, one B from the mum. But this is also possible. You get one B from the dad and a lowercase b from the mum, and it still would be have no knowledge. So it's not always possible for you to either predict or know or predict what someone's genotype is. So if you don't know which genotype is, usually write both. Ladies and gents, that's the information I want to give you guys. I'm going to spend this last